Imagine you are designing a circuit where you need to quickly turn on and off a component, perhaps a motor, an LED, or even a heater. The choice of the right electronic switch is paramount for efficiency, reliability, and overall performance. But with so many options, how do you ensure you pick the absolute best one for your specific needs? When deciding between a BJT or bipolar junction transistor and a MOSFET or metal oxide semiconductor field effect transistor for a switching application, the answer directly hinges on your application's unique requirements. There is no universally superior component. Instead, the ideal choice is the one that best meets the demands for switching speed, current and voltage handling, power efficiency, and cost. The core difference lies in their control mechanisms and how they conduct current. A BJT is a current-controlled device, meaning a small current flowing into its base terminal controls a larger current between the collector and emitter. For it to switch on effectively, you need to provide a sufficient base current, and it will have a small but significant voltage drop, the collector-emitter saturation voltage, even when fully on. In contrast, a MOSFET is a voltage-controlled device, where a voltage applied to its gate terminal creates an electric field that allows current to flow between the drain and source. MOSFETs generally exhibit much lower on-state resistance, known as RDS(on), leading to less power dissipation when fully conducting, especially at higher currents. This fundamental difference also impacts their switching speeds, with MOSFETs typically offering faster switching due to their voltage-controlled nature and lack of minority carrier storage effects seen in BJTs. To make your decision, consider these key factors. First, evaluate the required switching speed. If you need very fast switching for applications like switch mode power supplies, a MOSFET is usually preferred. Next, assess the load current and voltage. For very high currents and voltages, MOSFETs often provide better efficiency due to their low RDS(on). However, for simpler, lower power, and lower speed applications where cost and component count are critical, BJTs can be a simpler and more economical choice. Also, think about your available drive signal. If you have a current-limited source, a BJT might be easier to drive directly, whereas a MOSFET often benefits from a dedicated gate driver integrated circuit to quickly charge and discharge its gate capacitance. Understanding the nuances of driving each type of transistor can also be a game changer. For a BJT, you might use a current mirror to ensure a stable base current, or simply a resistor for low power. For a MOSFET, especially in high-frequency applications, specialized gate driver ICs are essential to provide the high peak current needed to rapidly switch the gate capacitance and minimize switching losses. Furthermore, consider thermal management. A MOSFET's lower RDS(on) translates to less heat generation at high currents, potentially simplifying heat sink requirements compared to a BJT for a similar load. Always check the breakdown voltage and maximum junction temperature in the datasheets. Ultimately, the selection between a BJT and a MOSFET for your switch boils down to a careful trade-off analysis. By systematically evaluating your circuit's specific current, voltage, speed, and power requirements, alongside considerations for driver complexity and budget, you can confidently choose the component that provides the most robust and efficient performance for your design.